Hi, my name is Sam Rapoport, and today I'm going to be talking about how robotic craft inform us about Mars. The information we've gained from the probes and rovers we've sent to Mars has transformed it in popular culture from a dead world filled with canals to the next step in human space exploration. So, my first question is why do we use robots and not humans? In Dr. Daniel Britt's words, humans are heavy, fragile, dirty, and vulnerable. Robots are just a more logical and cheaper first step. They don't need heavy food and water, you don't have to worry about a return trip, they're self sufficient, and they won't die from extended radiation. So then the next logical question is why do we have humans at all? Stephen Hawking argues that humans are necessary for humanity's long term survival in space. And if we're looking at just the near future, humans are still better for unexpected situations and are necessary for long term complex tasks, such as field studies. And plus, they're more popular with the public. So let's not put the cart before the horse, or the human before the robot. Robots are great for gathering data and making a safer human experience. So now that we decided robots are a better place to start, how do we go about using them? NASA's developed a fairly comprehensive yet simple plan. So I'm just going to give a fair warning before we start. I'm about to get pretty US-centric. That's because pretty much every mission recently, minus ExoMars, has been done by NASA. The only other exception to this is the Mars Orbiter mission by India, which was mainly just a practice run for more complicated missions. So that's why I'll be focusing on NASA's goals for space exploration. Here are NASA's four main goals for the Mars exploration program. 1. To determine if life ever occurred on the planet by looking for organic compounds in water. 2. Characterize the climate. 3. The geology of Mars to give better insight into Mars' and Earth's past. And 4. Prepare for human space exploration. The first strategy NASA's using to accomplish these goals was the Follow the Water program, which figured out more about the distribution of water, because as we know it, water needs life. Life needs water to develop. The next and current strategies are figuring out how habitable the planet was and seeking signs of life to see if it ever occurred on the planet. Now let's get to the good stuff, some actual robots we sent. The Mars Reconnaissance Orbiter launched in 2006, and its main objective fell under the Follow the Water program, to observe where past oceans were, and, in addition, it monitored the Martian weather and gave detailed surface views. The next probe we sent was the Phoenix Lander in 2008, which continued the Follow the Water program, and it studied the ice and soil in the Martian Arctic to learn more about the history of water on the planet. And it taught us that Mars used to be both wetter and warmer, and the lander 6 months later died a cold but expected death when its solar arrays were frozen over. Now let's move on to the big man himself. Curiosity, or the Mars Science Laboratory, if you hate fun, landed in 2012 and travels the planet taking soil and rock samples to tell us more about the geology and past habitability. And Curiosity rover also proved the feasibility of landing craft with the sky crane on Mars. The next probe was MAVEN, or the Mars Atmosphere and Volatile Evolution mission, which arrived in 2013 and takes detailed samples of the upper atmosphere and gas emission rates to show more how the atmosphere has changed over time and what role the sun has played in altering it. And dealing a solid blow to American exceptionalism, the European Space Agency has just launched ExoMars 2016, which includes both the satellite and lander. The satellite, named the Trace Gas Orbiter, scours the atmosphere for gases relevant to life, such as methane, while the lander, named Schiaparelli, informs us about Martian entry conditions, allowing more reliable and accurate future landings. The second part of the mission, ExoMars 2018, has an ESA rover and a Russian space platform. The rover is equipped with a 2-meter-long drill to search for preserved signs of life deep in the surface, and will communicate with Earth via the Trace Gas Orbiter, while the Russian platform takes extended observation of the Martian climate over a full Earth year. Back in the States, NASA has delayed the launch of the wonderfully named InSight lander until 2020, which its mission is to learn more about the Martian interior using a 5-meter-long heat probe to give better, wait for it, insight into how terrestrial planets like Earth were formed, more specifically the creation process of a core, mantle, and crust. The final robot NASA has in development is the Mars 2020 rover, shockingly set for launch in 2020. It has the same basic design as Curiosity and will give more data about the geology and weather of the planet, and will also collect rock samples that will hopefully be returned to Earth one day. It also includes instruments to test oxygen extraction from atmospheric CO2. So you may be thinking to yourself, old rocks and science are all fine and dandy, but how's this information practical in any way? Well, thanks to these robots, future landings will be more accurate and safer. We'll be able to solve problems about Mars' unfamiliar atmosphere before a single astronaut has to experience them firsthand. And within a decade or two, we'll need both humans and robots on Mars to take extensive tasks such as field studies and construction. Robots can shoulder the dangerous, laborious, monotonous, intensive work, while humans can handle unexpected problems and manage evolving projects such as research and field studies. Sci-fi authors have already speculated how this would work, such as Isaac Asimov and Kim Stanley Robinson. I, Robot, by Isaac Asimov, follows two scientists who work out the kinks in new robots when things inevitably go wrong, and shows the necessity of on-site human supervisors, because no matter how well-tested new technology is, problems will arise, and humans will need to be around to fix them. The early part of Kim Stanley Robinson's Red Mars shows a realistic view of how humans and robots will work together. Programmable robots would be able to do things such as manual labor, digging, construction, while humans would be on-site to oversee these projects, and then would be able to do research and manage evolving projects of their own. In conclusion, robots are a fantastic tool for learning about everything Mars: atmosphere, geology, chemistry, weather, and it gains us invaluable knowledge at low cost and no risk to human life. And when plans get more ambitious, we'll need to adapt and expand our use of robots to make space exploration cheaper, safer, and faster for all of humanity. Thank you.